All right. So in this presentation, I'm going to be looking at a company that wants to expand and how it correlates to credit card fraud. So a local credit card company here in the United States is interested in expanding to India. Surveys from US customers stated that fraud was the biggest deterrent from applying to a new credit card. So this company wants to determine the best marketing strategy for gaining credit card customers in the new country while alleviating fears of fraud using data credit from credit card fraud cases in India. All right. So this data set that was chosen to carry this out is a data set from Kaggle. It has 8,000 rows and 20 columns. A particular interest is none of them have any null values, which I particularly like. And here are the columns names. Not all of these columns will be used for the analysis. Okay, so we want to use this data to determine which card has the highest amount of fraud, which device is more likely to encounter fraud, which city has the highest and lowest amount of reported fraud based on their card type, and is a transaction currency, the card type, and device type a predictor of fraud cases. So let's go ahead and look at the data. For cleansing the data, there was 20 columns, as I said previously. 13 of the columns did not relate to what was needed to answer this question, so they were eliminated. Also, the data set had 316 cities, so I eliminated 296 of them and focused on the 20 most populous cities because I feel as if that will give the best information for answering the questions. So once the elimination of the data was done in SQL using Azure Data Studio, I finished with 470 rows and 7 columns. And now the data was cleansed and we can get to answering the questions about the fraud using data. All right, so let's get to them results. First, determine which card has the highest amount of fraud. I did this one in Python, and you can find the code for how I did this and also get the visualization code from my GitHub profile. But all I did was look at the frequencies of reported fraud cases. And out of the frequency of reported fraud cases, MasterCard had the highest, but it wasn't by very much. It was MasterCard 85 to 82 for American Express to 81 for Visa. So that was interesting. MasterCard had the highest amount of fraud cases, but barely, not by much. Next, which device is more likely to encounter fraud? So for this one, I tested this in R, and I used a chi-square test of independence to determine which device is more likely to encounter fraud. I also made the visualization in R. So you can check out the code that I did for this particular test in my GitHub profile. But do note that I was unable to save the code in R. So it is definitely in a PDF, but you can just copy and paste that code. And as long as you have the data set on your profile, you should be able to get the same thing, get the same result as I did. So after running the chi-square test, I got a p-value of 0.0579. And for this test, I wanted to be confident at a 95% confidence level. So that means there's not enough evidence to reject the null hypothesis and accept the alternative hypothesis. So there is not a significant difference between which device is used when credit card fraud occurs. And we can see in the bar plot here that the average rate of fraud for each device information, I don't like that as over half, I'll be honest. I'd be a little nervous about using the device to get a credit card for desktop and tablet. But we see desktop is 0.58, tablet 0.56, and mobile 0.46. So we can assume from this data, that desktop has the highest amount of fraud and mobile has the least amount, but the difference is not significant. So you cannot determine if which one's more likely going to have fraud or not, because They're just different, period. It's not a significant difference. Moving on, which city has the highest and lowest amount of reported fraud according to card type? So this one I did in on Tableau. I made a scatter plot in Tableau, and I simply went through each of the cities and each of the card types, and I looked for the highest point because the closer they are to one, the higher they are to have more fraud cases reported compared to no fraud cases. Because in the data set, one was a case of fraud and zero was a case of no fraud. So if a city had a lot of ones, they had a lot of fraud cases on average, compared to a city that had a whole bunch of zeros, they had a lower fraud cases. Right. So taking a look at American Express, what I like particular is that there's a city that has no fraud cases whatsoever reported for a particular card type, which is amazing, or it just may not be available in that market. Who knows? Um, so after looking at this scatter plot, I made the following table to determine who had the highest and lowest amount of fraud on average based by city. So American Express, the highest fraud was in Lucknow, and MasterCard, the highest amount of fraud was in Jaipur, and then for Visa, the highest amount of fraud was in Kolkata. And then for American Express, the lowest amount of fraud was in Visakhapatnam, and for MasterCard, the lowest amount of fraud was in Pimpri Chinchwad. And for Visa, the lowest amount of fraud was Jaipur. I think what's interesting is that Jaipur made the list twice. So that'd be something to look into, especially if I'm considering if I'm considering going with the company to Jaipur, if I would support that decision or not, just because of the different card types and how it made the list twice. Next is the transaction currency, card type, and device type of predictor of fraud cases. So I used a chi-square test of independence in order to determine the predictors. I did this completely in Python. You can see this in GitHub. You can see the code that I used for the chi-square test. I did test all of the assumptions before I did the actual test. And after performing the test, I got a p-value of 0.29, which wouldn't even be good at a 9% confidence level. It very much is not good at a 95% confidence level. So there was no significant relationship between fraud and the currency that was used, the card type that was used, and the device that was used. So we cannot say, based on this p-value, we could not predict fraud from either what you use to pay for something, what credit card type you use to pay for something, or what device type you use to pay for something. And we can correlate that to the heat map where, I mean, this is all over the place. For American Express, the different card types, I mean, some of them are red, some of them are blue, some of them are gray. Same thing with Visa, some of them are red, some of them are reds. Visa is actually pretty consistently red, but still, it can't predict where a fraud is going to happen. And then MasterCard, some of them are blue actually, and then there's the one red in the middle type of currency. So, however, the difference between these aren't significant at all, according to the chi-square test of independence. So it's a nice thing to note. It's a nice thing to look at. Something to definitely keep in mind to see which ones have the most red. But like I think I'm looking at it real quickly. It looks like desktop has the most red. But something to keep in mind. These differences aren't significant. They just kind of suggest a pattern, and it's based on just the randomness of the data. So something I want to consider some things I'd like to consider for the future. What factors could determine fraud that wasn't evaluated previously? I only evaluated 3 of the factors. There were way more factors that could be used in order to determine fraud. And then how much money was lost to fraud in cities with the highest and lowest cases of credit card fraud? Because it's one thing to say, hey, we have a lot of cases. It's another thing to say, hey, we have a lot of money missing. Those are 2 different situations. And then could logistic regression or a MANOVA test be used to determine the relationship between the currency type, the device type, and the card type, and if they're correlated to the number of fraud cases. So I was thinking like maybe using a fraud, not a fraud, a dummy variables for card type, currency type, and device information uh, to run logistic regression in the future. That might actually give me some more information and give me a better p-value than 0.29. But who knows? It might be exactly the same. Might be the same with an ANOVA. Who knows? If you have any comments, please leave the comments. I want to hear from you. Please check out my work on GitHub. Leave me any comments over there. Thank you for checking out my video and have a good rest of your day.